Hello and welcome to another one of D's ADD videos. Today we're going to be looking at Dalton's law for pressure and the concepts of partial pressure and mole fraction. When we have a mixture of multiple non-reactive gases, they each make a donation to the overall pressure felt in the container. The partial pressure is the pressure that you feel if we were just given the one gas measured in the same size container at the same temperature. The total pressure would be the sum of each of these partial pressures. And that's basically Dalton's law right here. So given a bunch of gases, each with their own partial pressure, you add them up, you get the total pressure. Now there's a few different ways they can give you this problem. They can give you what's called a mole fraction. So mole fractions basically have to do with the ratio of moles of a specific gas. In this case, we're talking about gases being mixed together, over the total number of moles of gases. If you're asked for a mole percent, then you just take this number times 100. Now, how do I go from mole fraction to pressure? Well, I take that mole fraction times the total pressure, and that'll give me the partial pressure. You might be also asked to calculate the mole fraction given the partial pressure and the total pressure. Either way, this is the equation that you will need to know right here. That's basically it for Dalton's law, mole fractions, and partial pressures. Again, quick recap. Partial pressure is the mole fraction times the total pressure. You can manipulate this formula to calculate mole fraction. Mole fraction is the individual moles over the total moles. And then Dalton's law says add the partial pressures together to get the total pressure. And that's basically it. Not much to it, okay? So practice, practice, practice. Watch the example videos. Thank you and have a nice day.